So just before we get into the chemistry of it all, I just wanted to take a moment to introduce myself properly. So as I mentioned, my name's Jada, and I'm a medical student. So I finished my 3rd year at King's College London, which means that I get to be sort of on the wards, following doctors and speaking to patients. And I get to see how sort of the principles of biology and chemistry that you learn at GCSE and A-level, they get used on sort of an everyday basis in medicine. And I assume that for the majority of you here with Elite Medics, you might have some interest in going into a healthcare profession into the future. So I'm going to be sort of trying to share that knowledge about how chemistry is used in medicine with you guys throughout the day. And I'm also happy to stay behind at the end of today's session to answer any questions that you might have about life at medical school or getting into medical school. But if I could just please ask, if you do have any questions about medical school, if you could just keep those to the end of the session, and let's just focus on the chemistry questions until then. My favourite subject when I was at school was actually chemistry. And the reason for that is that there are so many little mnemonics or acronyms that you can sort of make up that help you remember the content. And again, I'm going to be sharing those things with you guys today. Okay, so what are we going to be covering? So it's the organic chemistry topic. So we're going to be looking at different types of organic compounds, starting with looking at the alcohols. We're then going to look at the carboxylic acids. And then we're going to look at alkenes and the type of reaction they take part in called polymerization. And we're going to end the day after lunch by looking at amino acids. So please don't panic if those terms aren't familiar to you, because as I say, we're going to be talking through what they are throughout today's session. So by the end of the day then, there are a list of things that I'd like all of you to be able to do. So I'd like all of you to understand the importance of something called a functional group. I want you all to remember what the structure of the first 4 alcohol compounds is. I want you guys, as I say, to know what type of reactions that compounds from the alcohol group take part in. And similarly with the carboxylic acid group, to be able to know the structure of the first 4 compounds, the types of reactions that they take part in. As I mentioned before, polymerization is a type of reaction we're going to look at, which I would like all of you to understand by the end of today. And we're going to look at amino acids to end with, so I'd like you all to be able to remember what the structure of an amino acid is, and a reaction that they take part in, which is called forming polypeptides. Okay, so let's start off by talking about what organic chemistry actually is. A lot of people sort of find organic chemistry to be quite a tricky topic in chemistry. So I'd like to just start off by seeing how many of you have actually covered organic chemistry before, and how familiar you are already with the topic, just so I have an idea of how much you guys know. So we're going to start off with a Slido. So if you could sort of open a new tab and go to slido.com, you can put in the code for today, which is 363049. Or if you have a phone or a tablet, you can scan the QR code on the screen, and that will take you to Slido, which we'll be using today. And then once you've done that, you can answer the question, have you ever studied organic chemistry before? Okay, so at the moment, not very many of you have. So our options are, no, I've not studied it. Yes, but I still need some help with it. Yes, I know it very well, or you're not sure whether you've covered it or not. So this is just to give me an idea of sort of what your guys' baseline knowledge is, and how much you know already and how much of this is just revision. So I'll just give you guys a couple of minutes to get onto the Slido and let me know your answers. Okay, so it looks like the majority of you have not studied organic chemistry yet, which, as I say, is absolutely fine because we're going to go through all the theory today. I'll just give it a couple more minutes just for all of you to get onto the Slido, and just let me know where you're at with organic chemistry to begin with. Okay, so the consensus is organic chemistry is going to be a new topic for the majority of you. So we're going to go on to talk about what exactly organic chemistry is. So organic chemistry is the study of compounds that are found organically. So they occur naturally, they're found in the body, or they take part in the reactions that are sort of vital for life to occur. One thing that all of these compounds have in common is that they all contain carbon atoms. So all organic compounds contain carbon atoms. So because of this, organic chemistry can also be considered as the study of compounds containing carbon. So that's what organic chemistry is. In organic chemistry, it's quite common for compounds with similar chemical properties to be grouped together. And these groups have a special name. So compounds that have similar chemical properties and are grouped together, we call these groups homologous series. And that's just a fancy way of saying it's a group of compounds, a group of organic compounds with similar chemical properties. So, for example, carboxylic acids are a group of compounds which all have similar chemical reactions. They all behave similarly with sort of similar chemical properties. So this would be an example of a homologous series. Alcohols is another group of compounds, and these compounds also share similar chemical properties. So we can say that alcohols are another homologous series. So a homologous series is just a group of compounds with similar chemical properties. Now, the reason why the compounds in a homologous series have similar chemical properties is because they all contain the same functional group. And a functional group is just an atom or a group of atoms that all the compounds have. And that sort of atom or group of atoms influences the compound's sort of chemistry. So it influences how those compounds are going to react. And that's why all the compounds have the same chemical properties. It's because they have that same functional group, so that same atom or group of atoms. So for example, going back to the homologous series that we've already mentioned, the carboxylic acids, they all have similar chemical properties because they all contain a carbon atom, double bonded to an oxygen atom, bonded to an oxygen and hydrogen atom. So this would be the functional group of carboxylic acids, the group of atoms that all carboxylic acids have, and that's what determines their chemical properties. Alcohols, so our other homologous series, this group of compounds all contain the OH, hydroxyl, functional group. So they all contain this group of atoms, and that's what influences their chemical reactions, and that's why all alcohols have similar chemical properties. Okay, so we're going to start off by looking at the alcohols homologous series. And throughout today, what we're going to be doing is just looking at each homologous series and sort of the properties that they have and the types of reactions that they take part in. So alcohols is a homologous series of compounds that all contain the functional group OH, as I mentioned. And because they all contain the OH, they all have similar chemical properties. So for example, all alcohols are highly flammable, so you can burn them easily. And because of that, they make good fuels. So in some parts of the world, instead of petrol, they can actually use sort of alcohol in their cars because they're highly flammable and act as good fuels. Alcohols are also good solvents, which means that things dissolve in them really easily. And for this reason, They're often used in sort of medicines and cosmetics, so for example, perfumes and deodorants. Ethanol. So ethanol is an example of a compound that belongs to the alcohol homologous series. Ethanol is also used in alcoholic drinks, so things like wine and beers. And so in sort of day-to-day conversation, you might hear people talking about drinking alcohol, and what they actually mean specifically is ethanol. So that's the alcohol compound that's used in alcoholic drinks. So the first four members of the alcohol homologous series are methanol, ethanol, propanol, and butanol. And they have these structures. So for methanol, here you can see it contains that OH functional group, which tells you that it's an alcohol. Similarly, ethanol, our next compound in the alcohol homologous series, you also have that OH functional group. Propanol is the next compound, and here you can see the functional group again, and butanol, the next compound, again, the functional group. So all of the alcohols have this OH functional group, and that's the reason why they all have similar chemical properties. You can see the formula for these compounds. One thing you might notice just by looking at the structures of these compounds is that as you go sort of along the series, the number of carbon atoms increases. So in methanol, you've got just one carbon atom. In ethanol, you've got two carbon atoms. In propanol, there's 3 carbon atoms, and in butanol, there's 4 carbon atoms. Now, this is another feature of all homologous series, and that's that the number of carbon atoms increases as you go along the series. So all the compounds in the alcohol homologous series will have a different number of carbon atoms within them. And the names of the compounds can actually tell you how many carbon atoms are going to be in that compound. So if the compound's name starts with meth, that tells you that the compound is only going to contain 1 carbon atom. If the compound's name starts with S, that tells you that the compound is going to contain 2 carbon atoms. If the compound's name starts with prop, that tells you that there are going to be 3 carbon atoms. And if the compound's name starts with bute, that tells you that there are going to be 4 carbon atoms within the compound. And you might also notice that all of the compounds' names end with ol. And that's because they're all alcohols. So all compounds that belong to the alcohol homologous series end with an ol. So sort of in this way, you can see that the names of compounds are a bit like a code, where the beginning part of the name tells you how many sort of carbon atoms are in the compound, and the end part of the name tells you what homologous series the compound belongs to. So if I asked you to give me the name of a compound that has 3 carbon atoms and belongs to the alcohol homologous series, you could tell me that it's going to be starting with a prop and ending with an ol. So you know it's going to be propanol. So the names are a bit like a code. Okay, so the next thing I want us to have a look at are the types of reactions that alcohols take part in. So remember, they're all going to take part in similar reactions because they all have similar chemical properties, because they all contain the same functional group. The main type of reaction that alcohols take part in is a combustion reaction. Now, combustion is just a fancy way of saying that you're burning the alcohols. Remember, we said alcohols are fairly flammable, so they burn really easily. Now, whenever an alcohol combusts, what's actually happening is that the heat is allowing the alcohol to react with oxygen in the air. And whenever alcohols combust and react with oxygen in the air, the products are always going to be carbon dioxide and water. So that's always going to be the case whenever someone asks you what's going to be formed when alcohols burn in air, you can tell them carbon dioxide and water are going to be formed. So let's look at an example. So take our alcohol ethanol, and it's going to burn in air and it's going to react with oxygen. The products are always going to be carbon dioxide and water. And here we have the symbol equation for this. So we have C2H5OH for ethanol, which makes sense because we know if it starts with F, that means it's got 2 carbon atoms, and it ends with O, so we know it's going to have the OH functional group. So that shows you that that's going to be ethanol. And it's going to burn in air to react with oxygen, O2, to make our products carbon dioxide, CO2, and water, H2O. Now, whenever you see a symbol equation, especially in organic chemistry, it's really, really important to make sure that the equation is balanced. And I think that's just a really good habit to get into whenever you see a symbol equation, just to balance it in your head. And that's just important to make sure that in an exam situation, for example, you don't accidentally forget to balance an equation. And it's also great practice for you to always be balancing equations and really get used to doing that. So if we were to sort of look at this equation and look at the sort of reactant side, we can see that there is 1 carbon atom, there are 6 hydrogen atoms, and there's 1 oxygen here and 2 here, so there are 3 oxygen atoms. On the product side, there is 1 carbon atom, so, oh sorry, I read that wrong. So there's 2 carbon atoms on the reactant side, and on the product side, there's just 1 carbon atom. There are 2 hydrogen atoms, and there are 3 oxygen atoms. So we can see what's imbalanced here is the carbons. So we're going to need to times the number of carbon atoms on the product side by 2, which we can do just by putting a little 2 in here, so that's nice and balanced. But now we've also increased the number of oxygen atoms. So now there are 4 oxygens here and 1 here, so there's 5 oxygen atoms in total. So our carbons are balanced. Our hydrogens, we can see that there are 6 hydrogen atoms on the reactant side, but just 2 on the product side. So we need to multiply this by 3, which we can do by putting a 3 in front of the H2O. So now we have 6 hydrogen atoms, so that's nice and balanced, but we've also increased the number of oxygen atoms. So now we have 3 oxygen atoms here and 4 here, so there are now 7 oxygen atoms. So ending with oxygens, we've got 3 on the reactant side, but 7 on the product side. So what we can do is increase the number of oxygen molecules by putting a 3 here. So now we've got 6 oxygen atoms here and 1 here to give 7. So now each of those are balanced. That's just a quick bit of balancing equations practice. Apologies, I've written all over the next sentence. But the next thing I wanted to talk to you guys about is the difference between complete combustion and incomplete combustion. So the reaction we've just looked at is complete combustion. So that's where the alcohol reacts completely with the oxygen in the air. But sometimes there isn't enough oxygen present for the reaction to happen fully, and that's when you get incomplete combustion. This time, instead of forming carbon dioxide, you get carbon monoxide because there's not enough oxygen present to make carbon dioxide, which has 2 oxygen atoms in it. This is a problem because carbon monoxide is a highly poisonous gas. So it sort of gets in the blood and prevents the blood from sort of carrying oxygen to your organs, and it can cause death. So carbon monoxide is highly poisonous. So this might happen, for example, if someone was burning alcohol in an enclosed space. So say someone went camping and they have sort of a little portable hob and they're using alcohol as the fuel. They burn it inside the tent, but because the tent is in an enclosed space, there's not enough oxygen present, and instead of getting complete combustion, they get incomplete combustion, which makes carbon monoxide, and that's poisonous and might cause death of the people inside the tent. So that's a really dangerous situation that you might have in the case of incomplete combustion. Okay, so that was the main reaction that alcohols take part in. They mainly take part in combustion reactions. Another reaction that alcohols take part in is a reaction with sodium. So the metal sodium, which has the symbol Na. Whenever alcohols react with sodium, the products are always going to be a salt and hydrogen. So just like before, we said that the products of combustion of alcohols is always going to be carbon dioxide and water. Well, the product of alcohols reacting with sodium is always going to be salt and hydrogen. And what I mean by the term salt is that, the hydrogen in the alcohol compound is going to be replaced by the sodium. That's what the salt is. And then the hydrogen will be on its own as a gas. So let's look at an example to explain what I mean. So here's ethanol, so our alcohol again, and it's going to react with sodium. The products are going to be a salt and hydrogen. And the salt, you can see that the hydrogen atom in the alcohol has been replaced by sodium. So now you've got sodium ethoxide, which is just how you would name a salt made from sodium reacting with ethanol and hydrogen on its own. And when this reaction takes place, you'll visibly be able to see hydrogen being formed. Since hydrogen is a gas, there'll be bubbles. So you can always see that there'll be bubbles formed during this reaction. And as always, whenever you see a simple equation, it's great to get into the habit of just practicing balancing that equation. Okay, great. So the last thing that I'd like to talk to you guys about is where alcohols actually come from. So specifically, we're going to be looking at ethanol and how ethanol is made. So ethanol is produced whenever sugars, so mainly glucose, get broken down as part of a process called fermentation. So that's when organisms like yeast cells or certain types of plants, they break down sugar solutions to produce ethanol. So here's the word equation for what happens. Our glucose sugar gets broken down by the yeast or by a plant to produce ethanol, and also you're going to get carbon dioxide gas given off. So whenever fermentation occurs, it's always going to be glucose being broken down into ethanol and carbon dioxide. And as always, when you see a simple equation, it's important to make sure that it is balanced. So fermentation takes place sort of fastest at temperatures of about 30 degrees Celsius. And the reason for that is that the enzymes that sort of catalyze these reactions, they work best, so their optimum temperature is around 30 degrees Celsius. So if you want fermentation to occur, if you want to have ethanol being produced, you want to take your sugar solution, you want to take your yeast, you want to cover it and you want to leave it at 30 degrees Celsius. And those will be the best conditions for you to synthesize your ethanol. Okay, great. So in summary, we've already looked at the first homologous series, which is our alcohols. And we said that alcohols are a homologous series of compounds that all contain the OH functional group. And because of that, they all have sort of similar chemical properties. So for example, they all take part in combustion reactions, which is where they react with oxygen in the air to make carbon dioxide and water. They also all react with sodium to make a salt and hydrogen. And we also spoke about where some of the alcohols come from. So specifically ethanol, which we said comes from fermentation. So when yeast cells break down sugar solutions to give ethanol and carbon dioxide. And here's just a reminder of the structures of the first 4 compounds in the alcohol homologous series. Remember, if the compound name starts with meth, it has 1 carbon atom. If the name starts with F, it has 2 carbon atoms. If the name starts with prop, it has 3 carbon atoms. And if the name starts with but, it has 4 carbon atoms. One way you can sort of remember the order of these compounds is by making up sort of like a little mnemonic. One I like to think of is the mnemonic monkeys eat peanut butter. And that's just a sort of silly little sentence to help you remember that if the compound has, if the compound name starts with M, it's going to have 1 carbon atom. If the compound name starts with E, it's going to have 2 carbon atoms. If the compound name starts with P, it's going to have 3 carbon atoms, and B, 4 carbon atoms. So feel free to make your own sort of little mnemonic or anything like that to help you remember what the sort of names of the compounds correspond to. Okay, brilliant. So we've already achieved our first 3 learning objectives of the day. We understand the importance of a functional group. So that's what's going to determine the chemical properties of the compounds in the homologous series. We looked at the first 4 alcohols, methanol, ethanol, propanol, and butanol. And we looked at the reactions they take part in, such as combustion and reacting with sodium. So I've prepared a quiz for you guys, just to see how much you've understood and how much you've remembered. And with these quizzes, the fastest answers gets the most points. So they are timed, so try your best to get your answers in quickly. So I'll just give you a couple minutes to get onto the Slido so that we can do the next quiz. Okay, lovely. Nice little stars next to your name, Queen. That is very cute. I'll just wait for a few more of you. Hi, Grace. That is so aesthetic. Nice. Ultra vegetable. What does that mean? Welcome, non-bread. Okay, I'll just give you guys a few moments to all get logged on. And remember, you want to be speedy with these quiz questions, so fastest answers get the most points. Welcome, Shreya. Elite chemist, I like that. Nice, okay, I can see the numbers are still going up, so I'll just wait to make sure all of you are on the quiz before we get started. Okay, great, I think we are ready to start. So, first question then. Which of these compounds is an alcohol? Is it cycloethene? Is it propanol? Is it ethanoic acid? Or is it octane? Great, I can see the answers coming in nice and quickly. That's very encouraging. So just a couple more of you to get your answers in. So which of these is an alcohol? Okay, let's see what you've gone for. Okay, great. So 80% of you have said that propanol is the alcohol here, and 20% of you have said ethanoic acid. So the correct answer is going to be propanol. Remember, we said that compounds belonging to the alcohol homologous series, their names will end with OL. So they're always going to end with ol. and that's how you can recognize an alcohol. So really well done to those of you for getting that right. An excellent job, chicken like this, for that really great speed. That's awesome. And well done to our runners up also. Okay, second question. Are you guys ready? What is the name of the alcohol with only one carbon atom in it? Oh, excellent. Okay, I can see your answers coming in nice and quickly. Again, it's very reassuring. So which alcohol only has one carbon atom in it? Is it methanol, ethanol, propanol, or butanol? Okay, just waiting for a few more of you. Okay, let's see what you've gone for. So which alcohol only has one carbon atom in it? Excellent, guys. So almost 90% of you have selected methanol, and that is absolutely correct. So remember, we had that little mnemonic. We said monkeys eat peanut butter. So M first for methanol, which only contains one carbon atom. F would contain 2, prop would contain 3, and but would contain 4. So really excellent job. And well done, new winner this round, Megumi, with excellent speed. Really good job. Okay, third question. Are you guys ready? What microorganism is used in fermentation to produce ethanol? Was it E. coli? Was it penicillium? Was it alcohol dehydrogenase, or was it yeast? So what was the name of the microorganism that we said did fermentation to produce ethanol? Okay, just waiting for a couple more of you. Okay, well, let's see what you've put. So what microorganism is used in fermentation to produce ethanol? Amazing, great. So 83% of you have said yeast, which again is absolutely correct. So it's yeast. We're going to sort of break down glucose into ethanol and carbon dioxide. And we said that the enzymes in yeast work best at around 30 degrees Celsius. So that's the temperature at which fermentation is most likely to take place. The others, so E. coli, penicillium, not used really in fermentation, and alcohol dehydrogenase is the name of the enzyme in your liver which breaks alcohol down. So the correct answer is yeast. And really well done again, Megumi, for maintaining the lead. Excellent. Okay, so our last quiz question for this section of today's class. During fermentation, what product is made as well as ethanol? I did accidentally just say this, so hopefully you're all going to get this right. Okay, just waiting for a few more of you. So what is the other product that is made during fermentation? You're just waiting for a couple more answers. So what product is made as well as ethanol? Is it oxygen, hydrogen, carbon dioxide, or calcium? Okay, let's just take a look at what you guys have put. Okay, amazing. So 91% of you have correctly identified the correct answer, which is carbon dioxide. So we said that the yeast is going to break down glucose into ethanol and carbon dioxide. Perfect. And excellent job to Adam for having the fastest speed. That's really great. Okay, amazing. So I know the majority of you said that you hadn't covered organic chemistry before at school. So I just wanted to have a look at how confident you guys are feeling now, specifically about the alcohols topic. So now that you've spoken about it, spoken about what alcohols are and the types of reactions that are taking place in. So if you let me know on a scale of 1 to 5, with 5 being the most confident and 1 being the least confident, how you're feeling about the alcohols topic. So it's really great to see a lot of you feeling really confident now. That's really positive. Sorry guys, for some reason my throat is acting up. Okay, amazing. So most of you are feeling quite confident about the alcohol topic, which is perfect and really great to hear. So now we're going to have a look at some exam questions and how you might be asked about some of that knowledge that we've just covered. So we're going to do some exam questions for the next 10 minutes or so, and then we'll have a Q&A session for you guys to ask me directly any questions you might have about the alcohols topic, and then you guys can have a quick break. So starting with question 1, and it tells us ethanol, and here you can see the formula C2H5OH, can be made from ethene or from sugar. So ethene is just another type of organic compound, which we're going to discuss later on today. And the question asks us to complete the table, which shows the number of atoms of each element in the formula of ethanol. So this is a nice straightforward question, which is just assessing our knowledge to interpret what the formula says. So the first row has been done for us. So it tells us that the element carbon, the symbol C, there are 2 atoms of this in the formula for ethanol, which you can see there's a 2 by the carbon symbol. For the element hydrogen, which has the symbol H, we can see that there are 5 hydrogen atoms here and another 1 here. So in total, there are going to be 6 hydrogen atoms in the formula for ethanol. And finally, they told us that there are 1 atom with the symbol O in the formula, which we can see here, and the name of that element is going to be oxygen. And if you weren't sure what sort of element name the symbol corresponded to, you could always have a look at the periodic table. So when they say use the chemistry data sheet, that's going to contain the periodic table. And whenever you sit a chemistry exam, whether it's GCSE or whether it's A-level, the periodic table will always be given to you, so you will always be able to refer to it if you need to. Okay, so next question. The diagram shows how a solution of ethanol is made from sugar dissolved in water. The boiling point of ethanol is 78 degrees Celsius and the boiling point of water is 100 degrees Celsius. And here you can see the diagram. So here you've got your solution with sugar, water and yeast. So we can guess what's going to happen is that the yeast is going to break down the sugar into our ethanol and carbon dioxide. And yes, you can see that after 3 days, you've got the ethanol dissolved in water here, and the yeast has sort of sunk to the bottom. So part 1 asks us to name the gas produced during this reaction. Well, you guys already told me in the quiz that other than ethanol, the other product is going to be carbon dioxide, which is a gas. Part 2. What are the main steps needed to obtain pure ethanol from the mixture produced after 3 days? Well, after 3 days, you can see there's a mixture of water, ethanol, and yeast. And we just want to get the ethanol out on its own. So what we're going to have to do here is use our methods of separation, so our separating techniques. And for those of you guys who were able to attend last month's session, we spoke in quite a bit of detail about the different separating techniques that you can use. So the first one that you might want to use here is a method that helps you separate out the solid yeast particles from the water and ethanol solution. And a method of separation that will help you separate out a solid from a liquid is filtration. So that's where you sort of pour your mixture through a filter funnel that has filter paper in it, and the solid particles get trapped behind on the filter paper, whereas the liquid is able to go through. So the main step that you're going to need to obtain pure ethanol, first of all, you're going to need to perform filtration as your first step. And that's going to remove the yeast and give you your water and ethanol. The second step that you're going to need is to be able to separate out the water from the ethanol. And hopefully those of you who attended last month's session remember that if you want to separate out 2 liquids from each other, you can use a technique called distillation. And distillation is where you heat the liquids up, so you provide heat, and that's going to cause sort of one of the liquids to boil. In this case, the liquid with the lower boiling point is ethanol at 78 degrees Celsius. So you could just heat the solution up to 78 degrees Celsius, and at that temperature, all the ethanol is going to boil, it's going to turn into a gas, and that gas is sort of going to evaporate upwards. And hopefully you remember in distillation, you have what's called a condensation tube off to the side. So the gas is going to be able to sort of diffuse into the condensation tube. And around the tube, you have cold water. So that's going to decrease the temperature in the tube. So when the ethanol gas enters the tube and the temperature decreases, the gas is going to cool down into a liquid. So it's going to condense, and then you'll be able to collect the liquid in a beaker at the end of the condensation tube. So you're going to first filter your solution to remove the yeast, and then you're then going to perform distillation to separate the ethanol from the water. And that's how you would get pure ethanol. Okay, question 2. This question is about organic compounds. Wine contains ethanol, and they've given us the formula for ethanol here. Part 1 asks us to complete the displayed structure of ethanol. So guys, I'm going to ask you to just cast your minds back to that slide I showed you of the first 4 compounds in the alcohol homologous series. And remember that ethanol is going to have 2 carbon atoms in it because it starts with F. Remember, monkeys eat peanut butter. Eat is second, so 2 carbon atoms. And then we know it's an alcohol, so it's going to have an OH on the end. And the formula of ethanol tells us that there are going to be a few more hydrogen atoms attached. So there's going to be another hydrogen here and another hydrogen here. So that's going to give us our structure of ethanol. Okay, question 4. This question is also about organic compounds. Ethanol is an alcohol. One use of ethanol is in alcoholic drinks. Give 2 other uses of ethanol. So 2 other uses of ethanol, remember we said that alcohols are really highly flammable, which means that they can be used as fuels. And in some parts of the world where they don't have good access to things like diesel and petrol, they might use ethanol in their cars instead. Another property of alcohols we spoke about is that they're all good solvents, so things dissolve in them easily. So they can be used as solvents for things like medications, or cosmetics, so things like perfumes and deodorant. So things can dissolve into ethanol. Okay. So the next question, this is for you guys to let me know what you think is the correct answer. So if you wouldn't mind getting the Slido back up again, this isn't a quiz question, so you don't have to worry about having the fastest time, but just let me know what you think is the correct answer. And the question is, which gas is produced when sodium reacts with ethanol? So here we have the reaction between sodium and an alcohol. And what would the products be? Please let me know. Okay, so just waiting for a few more of you to answer the question, which gas is produced when sodium reacts with ethanol? So please remember that there were 3 different reactions we just looked at for alcohols. We looked at combustion reactions when alcohols react with oxygen in the air. We looked at the reaction with sodium, and we looked at how ethanol is made in fermentation. So this is asking you about the reaction with sodium. Okay, let's see what you guys have gone for. Which gas is produced when sodium reacts with ethanol? Okay, great. So the majority of you have gone for hydrogen, which is correct. So remember, when ethanol and sodium reacts, the products are going to be a salt and hydrogen. So when the reaction takes place, you're going to see those bubbles forming as hydrogen is produced. So really well done. Okay, so I have more questions for you, but it is already 5 to 11. So I think we're going to stop our exam questions there and come back to them at the end of today's lesson if we have time. And now I've got a Slido Q&A for you guys, so you can ask me directly any questions that you have about sort of what we've covered this morning about alcohols. So if you go onto the Slido, any questions that you've got about anything we've covered this morning, please let me know. And the moderators will be moderating your questions.